Good morning, everyone. Today I'll be doing the video. So I'm not going to waste any time. I'm just going to go right into the lesson. So as you can see today, your objective for the lesson today is how to write a linear function from a word problem. Okay. Um, a lot of you guys should be familiar with this by now. If you're not fully familiar with it, please make sure you familiarize yourself with this right here, because this is what is going to teach us how to write these different operations. All right, so make sure you take some time, go over this, refresh your brains with it. All right, so in order for us to write a linear function from word problem, there's a few steps that we have to take. All right, so the first thing that you're going to do is you're going to make sure that you read the problem. You have to read the problem, you can't skim through it. All right, the next thing, you have to identify the input, the output, and the y-intercept values, all right? Because these are what going to help us to write the equation. Your input directly affects your output. Your y-intercept is always your starting point, and you're going to see me refer to that throughout this video. And keep in mind that your slope-intercept form is equals to y is equals to mx plus b, where m is your slope and b is your y-intercept. So with knowing this, we're going to use this to create our equations, all right? So we're going to use this to write our linear function from word problems. All right, so let's go ahead and start. So I'm going to stop sharing my screen and switch over to my document camera, and we can proceed. All right, so now you should be seeing my document camera. All right, so pin this. All right, so on my document camera here, you see I have the steps here. So let's refresh. You got to read, you got to identify your input, your output, and your y-intercept. And we're going to use y equals mx plus b to solve the different equations. All right, so let's proceed here. All right, so first thing, the first example here, you'll see where it says Brennan prepares 8 kilograms of dough every hour he works at the bakery. So every hour he works, and keep in mind this word every, all right? So we gotta write an equation that shows the relationship between the hours work, which is X, and the number of doughs that's prepared. If X represents the number of hours worked and Y represents the amount of dough prepared, we can say that Y is equals to what? 8 kilograms of dough worked. We don't know how many hours, so it's going to be 8x. So here I know that the equation is going to be y is equals to 8x. All right. So it's as simple as that. That's what I'm going to do for my first equation. All right. So number of hours worked every hour, x represent hours. So it's it's 1 hour, it's 8 times 1, y equals 8. All right. And so on. All right. Let's look at our second example here. Example 2. Example 2 here. So I have Eva has already baked 4 cakes. All right. So Eva has already baked 4 cakes, and she can bake 1 cake with each additional egg she buys. Write an equation to show the relationship between the number of eggs, additional eggs, and the number of cakes. All right. So Y represents the total number of cakes. All right. So we have to consider the placement of X and 4 and X. All right. We have to consider the place of that. Since she has already baked 4 cakes already, that's going to be my starting point. So I know that's going to be Y is equals to something plus 4, because 4 is my starting point, or as it's often referred to as my y-intercept. All right. Well, Eva can bake 1 cake for an additional egg. All right. So the 1 cake for the additional egg, I can say it's 1 cake for each additional egg. So it's 1x plus 4. This is my equation. I could also have written this as y is equals to x plus 4. Do remember that here there's an imaginary 1, all right? This is an imaginary 1 here, so I could have just written my equation as y is equals to x plus 4, but I wrote it as y is equals to 1x plus 4. That way I can be consistent, all right? All right, let's look at example 3. Example 3 here. All right, so if we have Leroy says he's what, 20 seconds behind, and it falls behind another 3 seconds every day. All right, every, again, keep in consideration the word every represents a slope. Write the equation that shows the relationship between the day since the watch was last set and the time it fall behind. So if Leroy says he's what, 20 seconds behind at the beginning, that represents our starting point, r, our y-intercept again. So again, I can say here y is equals to something, all right, plus what? 20 seconds, all right? So it says for every, it falls behind another 3 seconds every day, right? Every, remember this represents my slope, so it's gonna be 3 seconds every day. We don't know how many days it's gonna be, all right? So 3 seconds every day, so I know it's gonna be y is equals to 3x plus 20. And pretty much this is just how you write a linear function from a word problem. That's how you do it, all right? Y is equals to 3x plus 20. So for every second or every day, you put the value there, okay? All right, so now what we're gonna do is we are going to look at the second set of problems, all right? So what we're gonna do here is I'm gonna go here, and our second objective, it says to evaluate a linear function from a word problem. So to evaluate a linear function from a word problem is all we're going to be doing is we're going to be given the function, and what we'll have to do here is to solve or evaluate by solving, all right? So now, again, I'm going to stop my screen, go to the second problem here, okay? So it says, this equation shows how a sample height depends on its edge, all right? H is equals to 3a, where the variable a represents the age of the sapling in years, and the variable h represents the height of the sapling in inches. How tall was the sapling when it was 5 years old? All right, so 5 years old, or 5 years old, represent what? This is years, right? So it says A represents what? The age. So I have 5 years. So I can say H is equals to 3A, but I know that A is 5 years old, all right, because it says A represents age. So I can say H is equals to 3 times, replace A with 5, all right, so this is going to give me H is equals to 15. So I can say at age 5, the sapling is 15 inches tall. Boom. All right, good job. So let's move on to the second problem here. Let's move on to my second problem. And again, remember, you can always pause the video. You can pause the video, go back, you can go back and forth, all right? So here it says the same thing. It says the equation shows the time required to ring up a customer is related to the number of items being purchased, all right? So here it says P, which is this, represent the number of items purchased, right? And it says T represents the time required to ring up the number of customers. So if it takes 19 seconds, seconds here represents T. So I can say T is equals to P plus 17, but it says that if T takes 19 seconds, if it takes 19 seconds to ring up the customer, I know that T represents time, so I'm going to put 19 is equals to P plus 17. It says how many items? How many items purchased is what? P. So here we're solving for P. So that means I must subtract 17 on both sides. Okay. So these cancel. So P is equals to 2. All right. So 2, it says P is equals to 2. It says how many items are being purchased. So in 19 seconds, 2 items are being purchased. And this is part of my answer. All right. All right. So let's look at the third and final question here. All right. So it says this equation shows the cost of Trevor's retirement party depending on the number of guests. So C is equals to 5G. So I can rewrite my equation. C is equals to 5G. All right, it says G represents the number of guests and C represents the cost in dollars. So it says, what is the number of guests? There can be a Trevor can afford to spend $15. So we got to figure out $15 represents C, which is the cost. So I can say 15 is equals to 5 times G. And we're trying to find G, the maximum number of guests. So here I have to do what? Divide by 5 on both sides because I'm solving for G. So here we have 3 is equals to G. 3 is equals to 3. So what does this mean? It means that if Trevor can afford to spend $15, he can have, we can say Trevor can have three guests if he spends $15. And that's a part of mine. So that is what the equation is. That is how we evaluate it. Again, if you have any questions, please come to office hours, see myself or Ms. Rivera or Mr. De La Sante, reach out to us and we're more than happy to help you. Some of you guys have outstanding work, so please get on top of that, come to office hours and get help. All right. Yeah, have a good one. Bye.